All right, so welcome everyone. This is Dev 305. Hopefully you're in the right room. This is not a infrastructure talk. This is not an IT pro session. This is for developers. Developers in the room, yo? There we go. All right, anyone who's an IT pro in the room who just came because there was MMO in the title? All right, I have my bunny. Excellent. All right, so what we're going to be doing in this session is running through a few things, but before we let's do some introductions. We did get a tweet asking for a behind-the-curtain entrance for people to burst around the corner and come out and do a song and dance routine and so forth, but instead we've decided to go a little bit more staid, basically because it's these guys and, you know, it's too far to run. All right, so I'm going to get them to introduce themselves very quickly.
I am Luke.
Aaron.
Steve.
All right. So that's us there. So I'm Richard Banks, first one, tall one, best looking one. And we have Luke, John, Aaron, Powell, Steve Nagy. Steve. And we're all MVPs, so there is a huge amount of MVP-ness on stage. What? All right. Had to be done. All right, and what can I say? All right, so what's this session all about? This session's all about... Yes, it's all about something mysterious, something special, something that you're all going to be so impressed by. So picture a world where grass is king and is taking over the universe. So
Hopefully that cleared it up.
So that covered it, right? So this is about an MMO called MMO, the lawn mowing MMO of choice. Anyone play Hover Bother as a kid? Own up. Oh, jeez. All right. Oh, well, you can only educate people so much. So what we're talking about here is an MMO called MMO. It's awesome. Which we happened to build in the last few weeks in our spare time. But the intent of this session is really to talk about the not quite 3 screens in the cloud. So you would have remembered, hopefully, from a few years ago, the whole talk about 3 screens in the cloud and where Microsoft was heading with their strategy. We're going to show how that's done. So hopefully you'll get some tips out of this, some things to learn, things to improve on from what we've done and actually do professionally. So we're going to be talking about design, architecture, some sharp edges, things to watch out for, and also some tips and techniques. That's lunch getting caught in my teeth. We're going to talk about team development. So here's our team, awesome team. Look at this talent on stage. Isn't it amazing? And then there's me. So screen 1 being phone 7 these days, not the Zune as we saw in the picture there. Screen 2 being the Windows PC, the Zune. Love the Zune. Windows PC, the cloud being Windows Azure. Got to say it correctly, right? Or Azure. Who knows? Anyone know how to say it properly? Yeah, good. All right, and then beyond the game, what happens when we get beyond the game and actually talk about the 4th screen, which doesn't really exist anywhere, the web in general? You know, all these other devices, like one of them in a Microsoft conference, but that's okay. Almost dropped it.
I'm so ready to get in there and just say it.
All right, so we're going to play. We're going to start this up. Luke? Just while I drive.
Okay.
You can commentate.
He is now starting it up. As you can see, it's a real live working app, at least in theory. Running. Bueller. Running.
It's okay. We're starting.
Where's the sound effects? Anyone do a lawnmower sound effect?
We heard it. big V8 lawnmower. It was awesome. And we will start. Come here. We'll start a second client just for fun.
Just maybe.
So Luke's up here emceeing.
Okay, so we're going to start up 2 instances. I feel like I should be calling bingo or something. 2 instances, and what we have here is a selection of courses that you may want to mow.
Well, why wouldn't you?
As you can see, we have a selection of all the world's greats.
Pebble Beach.
Augusta blobby thing.
St. Anton.
Okay, so once we've selected one of our fine courses, we get into our amazingly designed whole detail screen. Not a screen that I've ever actually named in a product before, but there you go. So what we have down the left-hand side is our players with us joining and our competitor, who Richard will now supply by logging into the other client. Feel the awesome speed.
Watch me hit enter.
And simulation. Okay, so both clients, at least in theory, are talking to the server and being synchronized. There we go. And as an exclusive, so I've attended quite a few demos from professional game developers, and they always go for this kind of airy-fairy, highbrow, lots of artistic effect type thing. What we have here is a fine example of developer art. Ooh. And there we go. Mowing kind of successfully. Feel that multiplayer, that high-speed adrenaline. Try and ignore the man wiggling his hips.
You're lucky you can't actually see him doing that behind the stage.
Uh-huh. All right.
Are we going to
Phone.
our illustrious second, third, fourth screen? While that's happening.
I'll just keep the phone in quickly.
Okay. Embarrassing screen silence now. Unnerving developer supplied sounds. Login name.
Ooh, login name. Doink, doink.
It's better than the usual selection. I think there's only so many times you can log in as Chunky Lover 78 without people starting to get upset. Okay. So, taking advantage of the... 2 things. First is taking advantage of the Metro theme and controls in our wonderful Windows Phone 7 client. Basically all the goodness of Windows Phone 7. Slightly different screen design, coming once again courtesy of the magic of developer art. Clicking on the I'm ready button and realizing that we need a brand new Windows player. It's like we're at Vegas. It's just that happening just that smoothly.
Oh, single player.
We really need to rename this starting an MMO in 45. And we'll just book a second session to actually get around to talking it.
Just tilting the screen. There we go.
This is why you're paid as a dev, not as anything else.
I'm here for the comedic value. And that's what happens when you close the emulator while debug's still running, as we knew. All right, so there's our game. Extremely high-tech, highbrow. So the point here is not really the game itself. The point here is the technology behind it and how we put some of these things together. So first up, let's just talk about the things that go before that. There's seats here, by the way, guys, if you want to just shuffle in, let the people up the back find a spot and get cozy with you and pretend you're on an airline.
They don't want to get any closer to you. They're trying
not
to
to
be
me, to
really
other
polite,
people.
but they really don't want to come any closer to you.
And there's always seats on the floor down here. We promise not to spit on you if you get too close. So in terms of organising a team, the way we developed this is we used a fairly ad hoc agile process. So I'm an ALM MVP and a Scrum trainer and so forth. So surprisingly enough, I decided it would be good if we used an agile process. And in Redify, that's what we do anyway. So for us, this was fairly natural. We jumped in and we said, all right, how are we going to work things? What are we going to do? Let's come up with a basic backlog of ideas and an approach to what it is we wanted to achieve. And then we argued for a little bit over where was too much scope and where wasn't enough scope and what's just getting crazy and are you nuts and all those sort of things. And then we started getting together and we said, let's be smart and do some weekly planning via Skype. So over the last 6-7 weeks, we've put this together and we've basically got each other on Skype because we're all remote. You know, we're doing this after hours. This is not during work. And some of us in Queensland, some of us in New South Wales, we're all on different sites, we move around, so get together each week and just coordinate. So what did you guys do this week? What have you achieved? What are we aiming to achieve next week? And just keeping ourselves on track. If you're doing any sort of development, I would assume you're going to be doing that. Who runs an Agile process themselves, by the way? Who's involved in Agile? So everyone who didn't put your hands up, are you in sucky waterfall mode? Oh...
I think the sucky is redundant, by the way.
Gifted waterfall. Or who's in Agifall, by the way, where you pretend you're being agile, but you're still doing waterfall? Okay, a few people. All right, that's probably even worse, because that's kind of between hell and heaven. That's that purgatory thing in the middle. It's just horrible. Then there's, of course, cowboy development. Anyone do cowboy? So that's where you got no process at all. You just kind of go, yeehaw, let's write some code, man. All right, so we use TFS.
Just hang on.
Should it be safe with him behind me? So TFS 2010 is the platform we used. So we use that for a number of reasons. Obviously for source control and coordinating our efforts, but also because we could tie a build server to this thing. And then do a build of Azure and everything else and make sure we could get everything up and running. And we used it for the work item tracking and making sure we knew what we were doing. And we also used it for a wiki and so forth. So we were able to track a few things. So here's a screenshot of our project in progress. You can see we've got our burn down chart sitting up there with a various amount of points that we allocated. We've got our product backlog sitting down the bottom in the little area there. We've got our work items up the top here and, ooh, red dot on Luke. Number of builds and so on and so forth. So we're able to see this information and keep track of where things are going. So the other guys didn't really look at that, but I certainly did because I wanted to make sure we were going okay. And they just waited for me to tell them we're not doing well, which is pretty normal, right? Do devs ever look at this normally? No. But it's still useful for us to actually track the project. There's our builds, a few builds. So we can see we've had a reasonable run of builds. We've got code churn, number of lines added and removed from the project, etc., or changed. And we're able to keep track of stats around this sort of information, as well as where we had... yeah. So we even did unit testing. Hey. Anyone think unit testing's a bad idea? Good, I'm just checking. So even though it's a good idea, who doesn't test? Yeah, okay, good. I don't need no stinking tests. I write perfect code first time. And we also did our wiki, so we had some notes around our wiki and so forth. So this is really useful things to do, and if you're doing any sort of teamwork, I would expect that you'd be taking advantage of tools like this to do your stuff. That said, here's a few stats. So from our last 7 weeks of duration, what did we actually do? We had 53 PBIs, as you saw in TFS. We've made 312 commits, which is not too bad.
You'll notice that he hasn't actually displayed the commit messages, like the titles given to each commit.
There's some special ones in there. 176 hours of effort between the four of us, which equates to about a week's worth of work for a normal team. A little bit over, I think it's about 5.5 days of team effort. So given what we've produced in 1 week, that's actually not too bad. 223 builds, 78% of them were good, which is all right. We had about 12% which were okay but challenged, which means the unit test failed. And then we had a few that were complete outright disasters, mainly during the periods where we were setting up the build server. So when you go through a build server setup and you're configuring things and getting everything running, it's normal for those those builds to break because you're making sure, do we have the Azure toolkit on? Do we have the phone toolkit and so on and so forth? And all up about 3,500 lines of code. So That gives you an idea of the size of the project that we've built and what's needed to produce something that awesome. Why are you laughing? All right, so one thing to mention, one of the things that hurts a little bit when you're doing remote team development with TFS is source control. Anyone agree with me? Yeah, so when you're working inside, and this is a TFS MVP talking, when you're working inside the corporate firewall and you're permanently connected to your TFS server, it's not really a drama. You can check in, check out, no problem at all. As soon as you get on the road and you're trying to do things on the train, for instance, or you're trying to do things at home where you're disconnected from your server, there's always this delay while things are getting checked in and checked out, and you can't easily switch between online and offline mode. It's a bit of a pain. So with TFS 2010, one of the things I tend to use personally is a tool called Git TFS. Has anyone heard of this? Okay, so it's for those who haven't, it's a little utility. It basically runs a Git repository locally that you can sync up to TFS, which is nice. So you can do all that online and offline stuff. Handles check-in policies for you as well, which is great. The other thing to note is that in the next version of TFS, coming up, they're moving from this server workspace concept that we've got at the moment to a local workspace concept. So you'll have no more of these read-only locks on files. You'll be able to effectively do a subversion style of development where you've got your code locally, you do your check-in, check-out locally, make your changes, and then push to the server after that. So it should make that source control friction that we feel when we're doing offline development a lot easier to handle. So when you're sitting on the train and you decide, you know what, I might cut some code. Let the person sitting next to me look at it and go, hey, I'm sitting next to a nerd. And it'll just be a lot easier for you. All right, so once we've set things up, we've got the team environment set up, now what do we need to do? We now need to move into our initial concept. So one of the things we did when we were initially kicking this around is actually try and come up with some design. So here's our sketch flow of the project so far. Phone client on Sketchflow. So I've got a Sketchflow project. We actually put this up on the wiki as well so everyone else in the team could see it and play around with it. And you can jump in, run this, press F5, and you can see this is running in the browser and we can do the mouse commands and everything else. So it's a nice way to visualize and get a feel for what the application is going to look and feel like before we actually get into it and actually invest in the development time itself. That's nice for the phone client. It's also useful for Windows clients and so forth. But if you're doing web, you can also use tools like Balsamiq, for instance, which is what Aaron did. So Aaron used Balsamiq here for doing the mock-up of how the web experience might be. And you'll see that the end result of that is reasonably similar to what we came up with. Who does UX design, by the way? Anyone? Your teams? No one. Seriously?
They all exited the room early.
They went, there's developers in the room, get out! So you guys don't do any design work up front, you just kind of jump in and start coding? It just doesn't work. Nice. All right, so the tool set. You might be interested in the kind of tools we use in this project. What do we use? So obviously from the Microsoft stack, we've got a few things here. This is our bingo game. Anyone playing bingo for keywords and everything else in this talk? So Windows Azure SDK 1.4, bingo! Game Studio 4 for the XNA side of things. Mango, we're using Mango for a specific reason, because it's new. ASP.NET MVC 3, Portable Library Toolkit, Silverlight Toolkit, the one that's just come out a couple of weeks ago, handy that it arrived, because that made a few things easier. And we're also using a number of open source tools. So NSubstitute for our unit testing, MVVM Lite, AutoFac, REST Snowmaker, SlimDX, jQuery, geez, there's a lot. There's some stuff. Why did we use so many tools and platforms? Because we don't want to write all this ourselves. It's much easier for us to lean on the shoulders or stand on the shoulders of others who've done all this for us and make life easier. And if you don't use or leverage open source these days, then your team is doing yourselves a disservice. There's so much goodness out there in the open source world. You guys should be taking advantage of it if you haven't. And if your managers say, no, we don't do none of that open source stuff here, what if someone stops maintaining it? What's the big deal? What if your commercial vendor goes under? It's exactly the same situation, right? What if Oracle decides to buy Sun? Oh, wait, hang on. So there's no guarantees. You use the tools you've got available at hand. You know, have a look at what's in the NuGet gallery, for instance. There's so much stuff in there. You can just go and jump on a NuGet, pull down some packages, and away you go. All right, architecturally, let's run through this very quickly. So how's this thing fit together? How's this thing fit together? Does anyone know? No?
Like Lego pieces.
Legos. We've got to say it American style, Legos. All right, so as you can see, we've got our 3 clients on the left. All of those clients, regardless of the type of client they are, talk via JSON REST services to an MVC web server, which is running in Azure, and that web server is offering a number of services. So we've got the login, the grouping, the holes and scores. Luke, do you want to comment on that?
No, I'm good.
All right, any 14-year-olds in the audience? Good. All right. And then, I've thrown myself. From there, we then have the game engine that's running in the background, and we're also doing data persistence into table storage, Azure table storage. So fairly simple in terms of the concept, in terms of the architecture, and that's actually quite a nice thing if you think about it. So to develop a nice multi-screens in a cloud application, all the pieces are there ready to go. You know we didn't actually use WCF. I wonder if there's a reason for that. Any WCF fans in the audience? Who likes their XML config? Yeah, okay, good. I hate WCF. Is the microphone on? All right, so that's it. So let's move on. Enough of me talking. I'm going to throw over to Luke now, who's going to talk about building the XNA client.
Ooh. Shiny.
Finally, power is mine. Mine. Woohoo! Okay, can we just quickly flick over to one of the clients? It doesn't matter which one.
You want to run it?
Yep. So, for those of you who haven't seen it before, Microsoft has a gaming technology stack called XNA, and it's basically their first suggested pit stop for doing anything game related. And despite the awesome developer art that's on show, there's actually some... actually, now that I've said that, can I have the Windows client? Oh, sorry, the Windows Phone client. I just want to... And can I have it cut into smaller portions? With salt. And the other fork things. Okay, so... And can you go into practice mode?
Yes.
Cool.
Anything else?
Ice cream? A cuddle? No. Anyway, sorry. Back to the story at hand. So XNA is Microsoft's... Shush, kids. Is Microsoft's game technology stack, which they basically hand out for free to everyone. So if you want to write games for Windows Phone, Xbox 360, PCs, Microsoft will point you towards XNA. Oh, yes.
Okay, I should just kill my breakpoints.
I said run, not that. Whatever that was, don't do that again. You were doing something untested, weren't you? Anyway, so XNA, one of its... oh, gosh.
Demo God smites me.
One of the things it can do, XNA, is it can natively deal with a whole load of popular formats of things. For example, if you're the artistic type and bear some talent above and beyond the amazing levels displayed here, what you can do is you can go into 3D Studio Max, Maya, any of those sort of 3D packages, create an awesomely realistic MOA, which will show up sometime before this segment completes. And once you've constructed your MOA, you can import it into XNA and use it quite easily. Just to be different, and because I recognise that my main thrill in life is actually writing code rather than dragging and dropping little things on screen, what I did is actually construct all the 3D elements that you see or will see on screen through code. So that's the terrain and the MOA and everything else. The thing to note is that one of the perks that XNA provides is has anyone here dealt with DirectX or OpenGL? Show of hands. Ooh. Okay. So for anyone who hasn't, DirectX or OpenGL. So the first 2 days of writing code with either one of those frameworks is you looking at what you hope is a blue screen. No content, just getting a blue screen up, and not the kind of Windows blue screen, just a screen. And then, if you're lucky, possibly with the aid of a book about yay thick, you will find yourself eventually displaying a 3D model, and then it's just fun and games from that point forward. XNA sits on top of DirectX and basically provides a whole load of smarts out of the box, and in XNA it's a drag and drop and thing.draw, and then you're up and going. Okay, so now that I've finished talking about that, we have something up on screen. I'm ready to go back to the slides now, Mr. Music. Thank you. Okay, actually no, now that I've seen what the slide is. One more. And now back. Can I have the lawn? Can I have the Windows Phone 7 back, please, now that I've asked for the other one? No, the first one on the left. Right, good. Okay, so, can you mow some lawn for me? Wow, there's a phrase you don't hear. Okay, so this is purely for geeky goodness rather than anything else. You may be thinking to yourself, I know how he's mowing that lawn, which doesn't sound any better. What he's doing is he's got himself an image there, and he's, erasing bits of the lawn as he goes. One of the kind of cool and quirky things about modern technology is we've evolved, quotes, beyond dealing with pixels really well. What most modern graphics hardware deals well with really, really well is actually triangles. Individual pixels really just slow the entire process down quite a lot. So if I was to take the approach of trying to modify an image on the fly by deleting bits of the grass texture, then this thing would be running so very epically slow, very, very slow. So what we do instead, and I will admit the awesome, awesome resolution of the grass kind of gives it away a bit, is the grass is actually a 3D model, and as we proceed along the grass, we actually drop the level of the grass. So a little tip at home for all of those who've seen this demo and are thinking to yourselves, gosh, I need to get into this whole virtual lawn mowing lark. All other knowledge be damned. Anyway, where was I?
Lawn state.
The lawn state. Anyway, that's lawn state. What this technique also means is, unfortunately, a little bit of extra work behind the scenes. So we have a funky way of constructing that lawn in 3D, and then we have some funkiness to actually track down which triangles of the lawn need to be cut. Now, you could take a really naive approach, in the nicest possible sense, and go looking for any triangles that happen to be directly under the lawnmower, and that's fine, but once again, even with a small lawn like this, we're dealing with quite a few triangles. So what we make use of is something called a quad tree. Sorry, first row, spitty. I can sing if it'll bring out that. No. Okay. So what we do is we make use of something called a quad tree, which is really just a sexy and a Nuth style of sexy of organizing data. So what it does is it basically breaks the world into this kind of binary search tree. So when I'm at a particular point on the lawn, I basically go, am I on the left side or the right side of the lawn? Okay, I'm on the left side of the lawn. Okay, now that I'm on the left side of the lawn, and am I at the front or the back of the lawn? Okay, I'm in this quadrant, and I just keep on doing that recursively. And it turns out, as with kind of most other binary search trees, that you can actually narrow down to, in this case, the triangles that you want really, really quickly. So even with a large number of triangles, we can mow the virtual lawn without too much issue. I feel I'm maybe warbling. So, no. Me? Okay, so is this where I talk about other devices? Okay, so as the yes, as the more awake of us might have noticed, I mentioned Xbox 360 in my little spiel about XNA. So what I can do is I can take, well, really the Windows client or the Windows Phone client and quickly and easily get a 360 version up and going. And just like the Windows Phone 7 client and the PC client, I have a good debugging experience. You know, Visual Studio allows me to inspect things, and it all works really, really easily. The actual process of doing that conversion, I mean, obviously, each one of these platforms has different performance characteristics, but for the most part, as in kind of usually around the 90% plus mark, it really is just a case of copy the project, make a few alterations, usually around things like input type. So you may have a touch screen for your Windows Phone, but obviously your 360 is going to be less than impressed if you start smudging your fingers across the screen. It's just going to look at you blankly like some sort of inanimate object. Okay, I think that's me done for the moment. Oh, network communications. No, you're stuck with me for another segment. Oh, the pain. Okay, latency and prediction. So, this is actually one of the kind of tougher subjects when it comes to network-related things, particularly in games, because unlike, say, a regular business app where there's really only a few select industries where you really care about things being in sync perfectly. With games, obviously, it becomes a real issue. If you're playing a first-person shooter and you go up and shoot someone, and then you know 3 to 5 minutes later they fall over, people are going to start noticing, possibly commenting in some bad way. The reality of networking, unfortunately, hasn't changed that dramatically over the last few years. Things have gotten, you know, faster generally, but the problem still remains that compared to the speed of the CPU, the network's really, really slow. There's what the analogy given in a lot of kind of game-related things, which is storing something in cache is the equivalent of, what is it? Writing it down. Storing something in RAM is the equivalent of writing it down and posting it. Storing it on the hard drive is the equivalent of writing it down, posting it, putting it in a time capsule, something like that. And then there's network latency. So it's the equivalent of writing it down, posting it, putting it in a time capsule, waiting for the Earth to dissolve in the universe just through natural attrition, and then picking it up and taking note of what's changed over the wire. So all games, network-related games, tend to do what's known as network prediction, which is, can you two demonstrate playing a really slow game of tennis for me? Like miming a slow game of tennis? Okay, so actually face away from each other and stand on one leg. That was just, don't worry. So imagine we have two clients and they're playing a game of virtual tennis together. That way. So client A serves ball, sends the message across the wire that the ball has been served. Strolling, rawhide.
What?
The ball has been served.
Oh. Am I supposed to hit it? Or?
That's generally how these things go. Okay, and back we go. And you can probably see where this is going. Okay, so what we need to do is concentrate on what's happening when the client is waiting for the message to come back. So get back. Go. Okay, I'll hurry up if you start playing better tennis. So while this guy is hitting the ball and the message has gone back to player B and he's waiting for a response, we need to show something on this guy's screen and pretend like things are happening as per normal. The way that we do that is through, as I mentioned, network prediction, and it's kind of a case-by-case basis. So in this case, what we're doing is we're kind of taking our best guess at what's happening with the ball. So, and in this case, we're replicating this look virtually, the technology, that exact look, until we actually receive a message back telling us what happened those many eons ago when he actually did hit the ball. The catch with this is that now we've got, on either client, we've now got two versions of what's happened. We've got our pretend version that we just made up, kind of guessing at what was happening, and we've got our real version that has just shown up on our doorstep saying what actually happened. The trick, well, half the trick with network prediction is not actually, making stuff up while you don't know, while you're waiting for a reply. The real trick with network prediction is elegantly removing your guess, your suspicion of what happened, and elegantly replacing it with what, the recorded transcript of what happened. And you'll be happy to know that we did none of that in our mowing simulation. I know. It's just that sophisticated. Okay, I feel I'm done for the moment.
Thank you, Luke. So, all right, so I'm actually going to not try and be smart and intelligent and do acting and all those sorts of things. I'll talk to you a little bit about the communication that's going on here. So, we wanted to use Windows Azure on the back end. I'm Windows Azure MVP, so that's why I was roped into this fanfare. And we wanted to, obviously enable the multiplayer aspect to this game, multiple clients being able to communicate, ideally doing all of that prediction stuff that Luke was just talking about. But we need to be able to ensure that, maybe if this phone, player A, sends their messages up to the cloud and receives messages back about what the moves are of the other players. Now, in an ideal world, in an ideal world, we probably want like a dedicated socket server where we could just have an open pipe, send connections back and forth, and so on. With your Windows Azure platform, it's not that easy because anything that's public facing goes through a load balancer, and if you want to scale up to multiple servers, the load balancers are actually round robin. So this means that the second connection, third connection might not be going back to the same server. So we kind of discarded the socket connection idea. We weighed up some ideas around WCF. For those of you who know a little bit about Azure, you might have heard of the service bus. This allows you to route through TCP protocol. Again, we found some problems getting connectivity with the phone and being able to create the equivalent client-side bindings on the phone. And we would have been able to achieve it with enough time, but as the guys have already mentioned, this is a 7-week project to get all this together. So we discarded that idea as well. We then thought, all right, well, we've got this concept of table storage. Table storage is really cheap, really fast, object data being passed around, through a REST API. And we thought, okay, well, this could possibly work. We could have all of the clients writing their moves straight to table storage, and we could have all of the other clients retrieving each other's information back from table storage. Now, there's sort of pros and cons to that. The main con is really around the security of it all, because in order to be able to write to table storage, you need to give your secure key to the phone devices. And that's probably not really ideal. Other than that, you can just open it up public access and have everyone read and write to it. So people could cheat the game. They could write in that they mowed all the grass and get around the whole system. So we decided to eventually go back through the web roles, go through the load balance, and instead of doing socket connections, we'll just do straight JSON. And I had an animation. I'm not sure where that is. But we decided to go MVC actions, returning JSON results. This allows us to return very small amounts of data and receive small amounts of data for our interactions. So every time that there's a communication from the phone up to the cloud, we're going via JSON and coming back down again. And which is pretty much what this slide was. So the other advantage of JSON is that it does give us the ability to support multiple different clients. If we want to take this global, we maybe want to do an iPhone app, if we want to do the Xbox thing, whatever the client's going to be, we've got something a bit more open in terms of standards for communication that's still quite concise. Because if you've seen something that's serialized for JSON, it's really, really quite small. In our case, we were sending messages that were basically the player ID as an integer and the basically a number that represented what the move was and how long it was going to be that move. Basically an array of those things. And a date timestamp, so it knew the last time it had posted a message, what messages it needed to receive back from the other players. So that's a very basic example of how to return JSON in a action result in MVC, and we're using MVC 3 for this. The portable library tools. So Richard mentioned it before. It's only a fairly new release. I might ask a quick question. Who's ever done some development that has involved maybe WCF services on one side and Silverlight on the other side? We're going to get a show of hands for that. And would you say one of the biggest problems is around sharing data contracts and operation contracts and those sorts of things? Who would say yes? Having a generic interface? It's difficult, right? You did it. Yeah. So, and this becomes harder when once we do it on the phone, because we have code libraries that need to get compiled for Silverlight runtime, for the phone runtime, for Xbox runtime, and the main .NET runtime. They are different compilation processes. So, if you have a library that, like a class library, that is maybe all of your objects that you're going to use for serializing and sending across the wire, but that library has references to some assemblies that aren't supported on those different platforms, you can't compile it for that platform. So they released the portable library tools to help get around this problem, and it includes a number of different assemblies compiled for different versions, allows you to basically compile to a single library to a bunch of different runtimes. And we needed that for our phone and for our XNA, as well as the server side for the library. So we found that quite useful, and the timeliness of its release was really useful for this project as well. So I'd probably encourage you guys, if you're doing that kind of work, to check it out. Games? Because the objects themselves, we're still sharing a bunch of stuff client side and server side. Yeah, JSON's just the mechanism for which it gets transmitted across the wire. We still didn't want to reconstruct those objects and duplicate them on both client and server side. Game state, who's that? That's not me. Back to Luke again.
I'll be quicker, I promise. Okay, so multiplayer games, just like when sitting around a board game as a child, playing Monopoly or something like that, generally it's a good idea if you don't have someone rabidly cheating and disagreeing with what they should have gotten, what they didn't get, and doing weird things with the bank. Same applies for MMOs, and in this case what we did is we made the server in the cloud the source of truth. And the way that we did that is that the server actually runs the very same simulation that the clients do. So despite the fact that there's no graphics happening on the server, it's actually behind the scenes doing a little virtual mowing of a lawn that doesn't exist, even less than the client. Suffice it to say, that's super, super meta. So we've got the same simulation code running on the client, same simulation code running on the server. In theory, assuming that all things are working perfectly, all of those should be in sync. But on the off chance that one of the clients is being weird for whatever reason, it just means that when we need to go and calculate scores and who won, we can... Was that me? No. That's good. We can calculate who won, we can calculate scores off the server, and basically take it as a given that the server was playing honestly as opposed to one of the players. The way that, well, just a peek behind the scenes of what that looks like. As mentioned before, we've got our comms happening via JSON REST in the middle here. Each client is receiving input from the user, and it's basically a list, a queue of inputs that have happened. Keep in mind that CPUs work a little faster than users, so believe it or not, it's not just a case of he pushed a button, queue of one, process, he pushed the button again, queue of one, processed. There is actually a queue being built up because, even on the Windows Phone, which is not the fastest device out of any of the ones mentioned, Windows Phone ticks along at, 30 to 50 to 60 times a second, seeing what the state of the inputs are. We take that queue of inputs and we run it through that simulation. We then take the simulation data and in a kind of MVC style. We have a display, a pretty independent display, which then takes that change data and displays it in lovely 3D. Hockey dokie. With that very same queue, we then send it across the wire. It gets processed on the server, and that server-side simulation is run. The other thing that the server does is it basically has a queue for each one of the clients, because what we want to do as a client, if I'm player 1, what I want to know is what happened with player 2 and player 3 in the intervening time. So we have queues for each one of the players, and we basically, for each one of these queues, we basically put in the data for all the other players. So player 1, we put in the data for players 2 and 3, so that when player 1's, when we're ready to send information back to player 1, we've got that queue of player 2 and player 3 data ready to go. We send it back across the wire, and using exactly the same kind of queue mechanic that we had for our local player, we just feed in the stuff from across the wire from the other players, and voila, we have multiple mowers on all of the clients and the server. Okay, so Steve mentioned how wonderful the portable library is. It does have one or two downsides. Do I have a follow-up slide to? I do. Okay, so hands up all of those people who think that that's a really sexy amount of files to have. So what we have here, and I think I'm correct in saying this is actually just a subset. So we have some files which were written originally to be across all platforms, which is good. And that's one of those funky portable library doohickeys that we mentioned. And then we discovered that, well, that's a really good idea, but as it so happens for the mowing simulation behind the scenes, we're using a lot of the maths libraries that XNA supplies. For any Microsoft people, just ignore that I said that. That's possibly a tiny violation of the licensing around XNA, but that's another story. Anyway, horrible licensing breaches aside, we wanted to be able to take advantage of basically the same maths across all the clients, and we really didn't want to roll our own version of Vector 2, Vector 3, and all the other funky things that XNA provides, which meant that the illustrious Mr. Banks used one of the .peek, there we go, used .peek to dutifully reverse engineer the XNA library, said here. What we have essentially is we have the completely legitimate Ivory Tower version, which uses all the libraries that we intended to. Then we've got it progressively degrading across clients as we get further and further away from the ideal situation, to the point where we have this, where we're using our own decompiled, recompiled version of some of the XNA stuff. We've got, I don't know whether you can make out the slight difference between the icons, but all of these are linked files, so that, at least in theory, we didn't have to type things multiple times over. For anyone who hasn't ever played with linked files, you know when you go add existing file, that little add button has a little drop down, which no one ever finds. I actually had to look it up online this time around. So yes, a proliferation of files, and as an added bonus, and admittedly we can't actually blame it on the Portable Tool Library, but it turns out when you've got Portable Tool Library, Azure, Windows Phone, and the multiple other things that we decided to stick into this single solution, the local build starts to go a little weird. You know rebuild all? That doesn't. And what's even better, it does it silently. So it's silently not doing anything, which is kind of zen, but not so good when you make an alteration to, say, one of these files, and you're in playing with this bit, And about, I don't know, 3 to 4 days after you've made that change, you suddenly do a proper recompile and discover that it's broken everything on this side. So, yeah, not so much fun. Can't really pin that down to anything in particular, but suffice it to say, right at the moment, there be dragons hiding just in let's pile everything into one solution across all platforms.
So there's another issue as well, which Luke didn't mention with the portable library tools, is that if you target at XNA, you're actually targeting x86. And when you run on Azure, what platform are you on? 64-bit. So all of a sudden we have bitness issues, and the XNA references, the reason we had to do the decompile is because trying to reference a x86 assembly on a 64-bit platform in the portable library tool thing just went and that was it. So we had to kind of
That's a technical term, by the way.
That is a technical term. All right, so let's move on a little bit. Threading and callbacks. Do you want to? I'll cover that one, or do you want it? I got it. Okay. All right. So one of the issues with any of these things where we're doing networking, we want to keep the application responsive, right? So of course, the good thing to do is when you make a network call block. Always, right? Everyone writes that. Everyone writes their network calls, and the first thing they do is make sure that's a blocking network call, right? Hands up. Own up. Come on. You know you do it. Everyone does it. So one of the things we have to deal with, especially with the phone and trying to keep the UI responsive, is make sure all our network calls have callbacks in them. So the way the client works normally is it's running this game update loop, which happens on a certain thread. But we're getting data back from the network, which is going to come back because it's a callback on a different thread, and we're updating collections and so forth. So we're bringing in game state, dropping in a collection. And what happens to a collection if 2 threads updated at the same time?
The
Collection
rhetorical sound
modified,
effect
all
is
that sort of thing.
broom.
We know that one, right? You've seen that? Who loves it? Yes. So we end up with sync locks all over the place. It's just something to be aware of when you're doing anything, regardless of if it's a game or if it's a business application with async issues. Always watch out for your threading and your callbacks on network calls, and always be aware of updating collections and that other threads are going to be jumping in there, because if you don't pay attention to it, it will bite you badly. I get the clicker. Ooh, Phone 7 client. All right, so this is my problem. So Phone 7, the Mango tools, one of the things that's happened with the Mango tools in the latest update is that you can run a Silverlight application and an XNA phone application at the same time, effectively in the one assembly. So you would have seen that. We had the panorama control at the start where we were sliding left and right and so forth, and then we were hitting a button and then we're getting launched into the game. We weren't starting a new application, we were just moving to an XNA window. So it's quite handy if you ever do any phone dev and you want to get a nicer experience because you are writing your own little homebrew game or something like that. Know that you don't have to write your own menuing system. I tried doing that. I'm not an XNA expert and it sucks badly.
My technical response as an XNA MVP is
there we go. All right. So feel free to use that. Take advantage of the Silverlight front end to do the menuing and make it really easy and so forth to get a nice Windows feel to it, but then launch into your game yourself. So it's a nice rounded experience. And looking at the client, you will actually see that sort of thing happening. So if I jump into the code very quickly here and scroll down using my left hand, we have game page XAML here, which is effectively the XNA part. So scrolling down, we're doing all our bits and pieces in here. We're grabbing the games device, and this is actually being called from just a normal navigate to page. So in your phone clients with the navigates, we're getting the navigation event saying we're hitting this page, and then we're automatically launching in and doing various bits and pieces. Yes, turn that off, that's fine. Jump back to the slides. Another thing we did, device ID usage. You would have noticed that when we actually started up the app, I didn't put in a username and password. One of the things we toyed around with was an idea of you log into a particular device. So if you normally jump on a phone, the phone can effectively become your password because it's your device, right? You're the one using it, you can sign in, you can use that device ID as a unique way of identifying yourself. And the nice thing is the phone actually does expose that device ID. It's an extended property, so it's not actually available directly out of the Mango SDK, unfortunately, but you can get to it through an extended property, and you put in a string with a device ID, and it comes back with a nice string which contains various characters. One of the issues we did find, though, is when we tried to put that into table storage to say this is a player and this is their ID, so we know that player on that phone, the device IDs come back with characters potentially that the table storage API balks on. So it gets slashes and dashes and whatever else in there. So what we had to do is actually base 64 encode it. It's not too hard. Easy way of doing things. And that way you've got a nice way of recording the user, knowing who they are, tying them to their device ID, and then moving on from there. Anyone used MVVM Lite or an other MVVM framework for your phone applications? So Caliburn Micro is another one that gets thrown around. There's a few others about the place. I found this probably to be the easiest MVVM framework for the phone. It's reasonably well documented as far as MVVMs go, and it made it quite easy to put things together. So I could concentrate then on using REST Sharp as my network API, getting data back, populating a model, and then just using the MVVM framework to actually paint the information on the screen. So all I did was just use the classic binding approach as you do with MVVM, and go from there. So it made it really nice and simple. Nothing too fancy at all. For those who, should I even ask these days, does anyone not know what MVVM is? Excellent.
Well, you did put it in a positive context.
Yeah, okay, everyone's going to put their hand up. I don't know. All right, so, all right, see me after if you really want to know. Another thing we had to do, because this is multiplayer, how do I actually prove that I can do multiplayer on the phone? Who knows Windows Phone emulator, you can only run one copy of the emulator. You know that, right? Guess what? Not true. If I go out here and I hit the deployment tool, oh, he's going to hold it up for me. Hit my application deployment, you'll see I can deploy to a phone device or the emulator, or, oh, look, emulator 2. Yeah, baby. So there is a little hack. It's not a supported hack, but if you do ever do anything where you want to run 2 phone emulators at once, you can do it. It's actually a matter of jumping in and just changing a couple of XML files inside the Windows Phone emulator directory. Really simple changes. Throw a few extra GUIDs in and give it a name. Nice and simple. It makes it a lot easier to work around some of this stuff. So if you really do want to get a feel for what happens if this happens on this device and then do I see the same on another device, and you've ever tried, I've got to have a physical phone and then my emulator and try and coordinate between them, this is really handy for development purposes. Sorry? Or you could use VMs if you really want to.
Let me short circuit that by saying you're wrong.
Ooh, I'm wrong.
So, yes, you're wrong.
Okay,
so it turns out that Windows Phone 7 emulation actually relies upon exactly the same virtual machine guts as, well, any other virtual machine thing that you care to use, which means, unfortunately, that you have the choice between running the Windows Phone 7 emulator and any other virtual machine. So that means if you, for example, have a love of, say, Windows Server 2008 R2 as your base metal config, and say run Windows 7 under a virtual machine, and then think to yourself, gosh, I'd love to run Windows Phone 7 in that Windows 7 virtual machine, you're going to find things explode on you rather badly. So the short of all of that is, if you're doing Windows Phone 7 development, it needs to be Windows Vista and later, and it needs to be on base metal.
There we go. All right, so that's nice. And there is a small other ouch we found. So with running the 2 screens in a cloud, and we're using XNA for this particular example, the way Windows XNA works in terms of the game update loop and the way it operates is different to the way the phone works, which means the timing is different, which is a pain in the butt when a lot of your calculations around where you move things and where the mower updates and so forth happens are on different timings. So you don't have exactly the same code that you can use. So again, it's a bit like that portable libraries tool where we're using mostly the same code, but kind of not at the same time. And you have to do a similar sort of thing with that. So if you do ever do any genuine 2 or 3 screens in the cloud stuff, just be aware of that. Table storage, I'm going to hand back to Mr. Nai.
I think I only have one slide, don't I? So, table storage. I mentioned before, I'm not sure if everyone's across table storage, but it's basically a way you can serialize an object and stick it up in this key value store up in the cloud. Very fast to write and very fast to read. Has some built-in partitioning by default. Our data, beyond the game data, we have a lot of other data like, what are the holes that you can play, what are the groups that are forming for players and things like that. And, there's not a lot of relational data in this. So SQL Azure, which is the SQL Server in the cloud option that you've got in the Windows Azure platform, lets you do full relational database type storage. And we didn't really need that at the end of the day. We could have just as easily been storing this stuff in SQL Azure. We would have had the benefit of transactions and things like that. But table storage is fast and it's available via REST API. So, and not to mention the fact that it's about 200 times cheaper as well. Okay, SQL Azure you're looking at around $10 per gig, whereas table storage you're looking at around 16 cents per gig. So it's big price difference. And even though we weren't paying because I got a free account as an MVP, but we still wanted to be economical and, blah. So that's pretty much the main reason why not SQL. We would have had to think about partitioning in a lot more detail. At the moment with table storage, when you submit a record to table storage, you can submit a partition ID. Anything that has the same partition ID ends up on the same physical node. And all you have to do is come up with a nice strategy with the partition IDs that you give to your objects that will ensure them going to different storage nodes, which makes it even faster to doing that writing and retrieving. So because we get that for free, that's another reason we went for the table storage. We took it a step further and we decided we'd be good developers and abstract away the fact that it is table storage with a typical repository pattern. Who's familiar with the repository pattern? Yeah, a very fair chunk of you. So it's just a good way to abstract the act of adding objects, deleting objects, and updating objects. Updating is not such a big deal because we have self-tracking objects and things like that. And we created a table storage repository, and that allowed us to use, Richard mentioned before, one of the things we have is autofac. We use that for our inversion of control container, which means we can do a dependency injection everywhere throughout our app. So all we have to do is inject iRepository of player, iRepository of whole, iRepository of game move, whatever it is, into our app, and not have to worry about the underlying implementation, which allowed us to write unit tests and be good, agile developers. One of the things that caught Richard out was that the table storage types are actually quite restricted. You have to jump on the website and have a look at the types that are supported. And decimals weren't supported, and we used decimals as one of the types with the game moves. I think the duration, was that right, for a move being enacted? And but like doubles and singles are supported, so I don't really see it as being a big deal. But Richard made a big hoo-ha about it and wanted to put it on a slide in Tech Ed Talk. So there's no decimals in table storage. You'll remember that. Some other things you can't have in a table storage object. You can't have complex objects. So you can't have a foo that has an instance of a bar. Okay, you have to have simple types. And you also have to, when it comes to arrays, you can't have an array of integers or an array of strings. You can have an array of bytes. So the types are quite small, but that's so it can speed up the serialization process and the read and write process from table storage. So there is a reason for a lot of those types not being supported. Now, with table storage, the IDs that you write to the database are actually strings. And you obviously want to guarantee that they're going to be unique. Because this is not a relational database, we don't have, an identity column that we can have an auto-incrementing ID. So we considered, all right, well, we'll use GUIDs for, good.newGUID for, new data going into the table storage. But when it came to the player IDs being submitted back and forth from the phone all the time, we wanted something a little bit more concise than a GUID being thrown around, across the wire all the time. GUID's quite large and bloated. We wanted small numbers. So we wanted to have integers, and we needed to find a way to guarantee the uniqueness of integers for our player IDs being created. Now, if you can imagine, our app's been deployed, and the server side of this might be deployed across, maybe 5 servers, 5 web servers, automatically load balanced. We need to guarantee that web server 1 and web server 2, when they go to generate an ID, are not going to generate the same ID for a player. So there's a project here called Snowmaker, which is released by another Azure guy at Redify called Tatham Oddy. He's a big Azure fan, and he ran out and made this little third-party framework called Snowmaker, which will generate IDs. It'll use a centralized repository like table storage as kind of like the identity generation location, and we'll guarantee we'll get unique IDs. So Snowmaker came in really useful for us. This project's only been released in like the last 4 weeks or so. So again, it was very timely for us to use that on this particular project for our IDs for our players. We still use GUIDs for the other things like the holes and the groups and stuff like that.
All right, so very quickly, game completion. Just in the interest of time, so I can jump through to a few other things. Obviously, when a game completes, we need to send a message. So one of the things we do is we say, game's completed, yay, let's send a message, send it to a queue, because we want to then open that server up that's serving the game at the moment for something else. We send a message to a queue so that then another back-end web worker role, a worker role in Azure can pick that message up out of the queue and then create entries in the score table. So that as the game completes, we can then drop that in and update the scores accordingly, which is cool. And that's obviously where the worker role gets used. So one of the other things you can do with worker roles is obviously anything that's asynchronous from a processing point of view is just drop whatever you need into a message queue, let the worker role pick it up, process it, and go from there. So nice and easy. Moving on, let's get outside the game and throw it over to building the website. And the last member of stage who hasn't talked yet has been very bored up here, Aaron.
Yeah, I am actually here for a reason, not just to stand back there and make snide comments to my fellow presenters. So we wanted to have an experience like beyond the game, as it says. We wanted to have a way that, like, once I finish, I can show off my scores and just how awesome I am at lawn mowing, because that's something that I like to go home and brag about to my friends. So, whoop, I pressed the wrong button. There it is. Oh, I'm not used to this clicker. So, obviously a web app is a good idea of what we wanted to do with this, and what we wanted to do was a single page web application. If you remember back right at the very start of this talk where we had the mock-up on screen, we just had a series of tabs, and hopefully Richard can now flick to the web app. I saw it, there it is, yay! So you'll see we have a bunch of holes listed down the side. So these are the various holes that we had on the different clients. Clicking on one of those will update our UI over here, and you can see, hey, look, I did 34 minutes. It took me to do it at one point. And apparently that was today at some point. Yeah. Oh, no, it was a while ago. So all of this is, we wanted to do this in a simple way that we didn't have a lot of code that we were having to write, and we wanted it to all happen kind of in browser. So if you go to the different tabs, again, we've got the same list of holes down the side, and you can click on them, and all this kind of stuff is persisted in the client state. If you go back to slides for me. Excellent. So we used a couple of JavaScript libraries for this. The first one that we used is Knockout.js. Hands up who's heard of Knockout.js before. Hands up who thinks Knockout.js is cool. For those who haven't heard of Knockout.js or don't think it's cool, I'm not sure why you wouldn't think it's cool, but essentially it's an MVVM library in JavaScript. So the kind of things that you'd be familiar with if you've been doing Silverlight development, it's taking that kind of a concept into the browser and being able to do it from JavaScript. So this is an example of one of our tabs. So this is the Today tab, obviously. And here I've got a data bind syntax, and this is something that Knockout introduces itself. And then we do a data binding that, again, if you're familiar with Silverlight development or WPF development, you'd probably be familiar with an inline binding like this. So what I'm doing here is I'm specifying that I've got a template that's going to have a particular name here, and I'm going to provide it with some options. What I'm doing with these options is allowing me to reuse this template across every single tab. So we have very little HTML that we're having to duplicate for each page. Here's an example of a template. This is done using jQuery templating, which is the default templating engine with Knockout.js. So you can actually load in other ones. I'm not really sure how you do it. Just use jQuery templates. It's so much better. All we're doing is we're going through our view model, which I'll come to in a moment, and we're generating a series of links that we'll be listing down the side. And again, we're binding some information here. We're binding a text property, which is what will go between the opening and closing tag, and we're binding a click function onto it. So here's a slightly bigger example of a template. This is what we display on the right-hand side of the screen. So this is the actual player information. And again, we're doing something simple like going through the collection of holes that are now listed in our view model, and we're looking for ones of a particular mode. So the mode is what I'm passing in here. So it could be today, it could be this week, could be this month. Finding the appropriate ones, and then just listing out, again, some HTML, doing some binding, such as putting player name in, click functionality, etc. So how do we actually get this data back to the client? I decided to use another open source library called Amplify.js. And the idea of Amplify.js is it simplifies the way you would do a RESTful interface with JavaScript. Rather than having jQuery.ajax everywhere that you interact with, here I'm defining a request that's going to happen. I'm giving it a name. I'm saying that it is going to be an AJAX request. Setting what URL that I want to go to. And what's important about this is I can do caching. So Amplify.js allows me to have inbuilt caching into my UI. So as I'm going between tabs, or if I'm doing something that would force a refresh of the holes list, it will immediately go to cache up until the cache expiry time is gone. So this means that our client application is going to be a whole lot faster. To actually get the data back from a request that we've defined, here we use, again, the Amplify API. We're passing in the list holes, which is the one we defined back here. And we pass in our callback function that we want to do. And this is where we're dealing with building up our Knockout.js view model. So I'm getting a callback that's been fired from Amplify.js. So after its AJAX call has happened, it comes back, gives me back a list of a collection of holes, which are coming back as our JSON response. I'm just doing some updating to it so that when I do a mapping from JavaScript, so this is an extension on Knockout, it allows me to take a JavaScript object and turn it into a Knockout object rather than having to write all that code out ourselves. It will just automatically convert this object that I've got here. Lastly, I'm setting up a couple other things, such as some callback functions for loading scores, loading players. I've left their examples off. And the last thing we got to do is actually do our binding with Knockout. So this is how you take your view model. It's similar to if you have a data context in Silverlight WPF. This is where you provide your view model for, in this case, a section of our DOM. You can do this at an entire page level. So if you've got a large view model which is representing everything on your particular page, you can just provide it the view model instance itself. The only problem with that is it can become very slow if you've got a large DOM, because Knockout.js will parse through everything on the DOM and look for all the binding syntaxes, and that can take a long time if you've got a very large page or a very complex page. So I think that essentially wraps it up for what I wanted to talk about in the web. I'm doing another web session tomorrow. Seeing as we're almost out of time, I thought I'd just plug my own session tomorrow instead. Come and see. I'll be talking more about things such as Knockout and Amplify and a couple other things like that. It's Dev 203.
Nice. All right, so what else would we do? Because obviously this awesome game isn't quite ready to take on World of Warcraft yet. We'd obviously do a bit of sound and graphic design, think maybe about richer gameplay challenges, MOA customization. There's all sorts of things we could do. We actually tossed around this idea as well, using Canvas and doing 2D replays. Because we're storing game moves in table storage, we could actually take those and replay them and show them in the Canvas. So you could be in the web browser and go, show me my last game from a top-down view, and watch the little mowers running around, which would be kind of amusing. We'd have to deal a bit more with sharding and game servers, as we know. Probably improve our networking and start using binary serialized JSON. Table storage, probably hit screen 3 and get that full 3 screens in a cloud experience. Deal with security and hacking, automate our Azure deployments off the build server, and much more, as you would expect. So that kind of wraps us up. But just before we wrap up properly, let's just lastly run through a few things. There's a whole bunch of links there. We'll have that posted on our various blogs, I'm sure. You can, if you submit your evals and all that sort of thing, win a touch mouse. Ooh, hardware, free. So that's always good, and TechQuest and so forth, and I've done all the plugs. Well, actually, no, I haven't. There's one more plug. This session has been proudly brought to you by Talking Shop Down Under as well, the podcast for developers by developers, hosted by yours truly. Thank you very much. Pleasure. Been here a while. No, okay. All right, that's it for us. We're just about out of time. So any questions? Or you've all been baffled into silence?
Yeah.
Down here.
Oh, it's completely unrelated to
Unrelated's good.
the phone on the floor. Can they come and see me?
All right, if anyone finds a phone on the floor, we'll teach you how to play the game with your newly won phone.